Good evening, everybody. Welcome to another Saturday night with me, Avacor, working on the wonderfully named Project Longshot here. So, first of all, sorry I missed the stream last week or last weekend. Had something come up, sort of, so had to do it. But we're back this weekend, looking at it. And last time, we managed to add a lot of color to the scene here, allowing us to render some green and some gray and a little bit of brown. But what we're sort of missing at this point is that we want we sort of have these weird glitches where we're rendering half a block in one color, half a block with one texture, half a block with another texture, and this was due to the way we were storing data for our vertex rendering or for our chunk rendering. So the first thing we're going to look at today is to rework our chunk renderer. First of all, to get rid of this, but also currently, let me switch code at the moment. There we go. Currently, we have two vertex buffers for our chunk, or two sets of buffers. We have a global vertex data, and then we have a set of local vertex data. And the idea right now is that we have sort of vertex positions and normals and other stuff. Where is it here? Global vertex data. So positions, texture coordinates, and normals are in the global vertex buffer, which is shared between every chunk renderer. And then we have a local vertex data, which just is the material, which is for this specific chunk. And one of the things I want to do today is I want to merge these two structures so we only have one set of vertex data, and that's local data. So we have empty global data. And the reason for doing this is that later on, I want to do something called dual contouring, where instead of the world being blocky, we actually try to smooth it out a little bit. And that means that we won't be able to at least share the X, Y, Z coordinates. And once we're getting into that point, we might as well also, and we won't either be able to share the normals. That just leaves us texture coordinates, and that's not really worth doing that much for. So we're going to be merging all of this together. But this is going to be basically a major rework of the chunk renderer, because we kind of need to, we need to redo a lot of this. Now, one of the other things that we might do while we're at it is here we're every frame doing a lot of bind buffers and setting up vertex attributes. We can save all of this in I think it's a vertex array object. So we just activate that and it sets up a lot of this stuff for us. There we go. I've also managed to figure out why my graphics card tends to crash, but I haven't figured out what to do about it yet. The browser in OBS doesn't really like my setup for some reason, and that's causing the graphics card driver to crash, which means it has to be reinitialized every once in a while. So that's a lot of fun. Hey Panda, how are you doing? Anyway, so one of the interesting things is when we're sort of working through and generating our local data, I'm just looking through because we have the index buffer here, which is done by this generate index buffer function. It walks through a chunk and then it decides whether it wants to add a face, X positive, X negative, Y positive, and so on down through. We are basically, whoa. Another little graphics reset there. I had some interesting artifacts on my screen for a moment. We are going to basically drive most of our logic through these functions. So for each of these, we are going to add the necessary, not just the index buffer, but also the local vertex data is going to get added, and we are going to generate everything through these functions is sort of my idea. So what we're probably going to want to do is rename this, and we're going to kill off the generate local vertex buffer and global vertex buffer functions because they are not going to be needed. Of course, we're still going to be doing some of it, but essentially this is what we want to do. So when we do this, first things first is we want to move all of this data over. So we move our global data into our local data here. Our global vertex stuff is disappearing, so I'm just going to start by commenting it out. Like so. Actually, we're going to keep that. No, we're not going to keep that around. And that's the global vertex data. And for local vertex data, instead of having a standard array, what we're going to do is we're going to have a vector, so we don't know the size of it ahead of time. But that does allow us to add dynamically to it, which we're going to want to do when we start doing our generation of data here in a moment. We're also going to comment this out. So we should have not much left of the global vertex data. This should definitely not compile. What I'd like to do is also the generate functions up here. We no longer, well, the generate index buffer is going to have a new name. We no longer generate vertex buffers and so on. We're just going to have one called generate buffers here. And instead of doing all of this, we're just going to call generate buffers here. And then we call generate buffers. Okay, I'm having a surprising amount of graphic card problems today. This might get a little bit annoying at some point. One thing that we probably should do, and which I can see is we're doing a little bit wrong, is up here, instead of generating the buffer every time we go through, or creating the buffer every time we go through, we should do that when we construct. So I want to generate a buffer for the index buffer and one for the vertex buffer. There we go. So when we're done all of this, so when we've generated, we've called these add phases. We then find our index buffer and load data into it, but we also find our vertex buffer, which is just a GL array buffer here. And then we find the vertex buffer. And then we're going to load in data from our vertex buffer. Now this is not GLU in short, this is vertex buffer. No, not with vertex buffer data. Local vertex data. And then we have our, again, size of our vertex buffer. So this is the new stuff that we need to do. So when we render, if our chunk version is not matching, then we're going to want to generate buffers. Now here we have all of this wonderful GL bind stuff. For now, we're just going to keep this as being, we bind our vertex buffer, so we don't need to bind anything else here. Then we look at local vertex data, because that's the stride we want to take. And then we need to look at the offsets here, which are these things again. They've just been moved from the global over to the local. I just want to check that these size t, well, they're actually defined later. So generating global vertex buffer, we no longer do that. And we no longer generate a local vertex buffer here. The vertex index function no longer exists because I don't need that. We're going to take a look at all of these functions in a moment. So global vertex buffer data and all of that no longer exists. These size t's still exist. They've just been moved into the local vertex buffer data. And there's still the offset of these various elements, so that gets us the correct offsets into our array. So far so good. Now the trick is we need to update our chunk renderer directions here. So we have an add face x positive, x negative, y positive, y negative, and so on. Now these are going to be very, very similar. One thing we do need to do is that we need to pass in the material that we want to use, which we get from this wonderful little call here. So what I'm going to do is I'm just going to create a quick variable here, material. And then we can pass that in along with everything else. So for these functions, they need to take an extra parameter. And this parameter in this case, just want to check the definition here of the chunk get. So get, there we go, returns a block t, which is of course the block type, currently a 64-bit integer. So we're probably going to be casting that down a little bit. But we have the concept of a block t, so that's what we're going to use. So a block type. And then we're just going to expand all of these so that we can call them. And then for the case where we're adding an x positive face. Now for an x positive face, you can see we're also indexing the indices. Technically, I'm pretty sure we have that available on the index. Or are these actually static? No, they're not static. So there's no reason to pass in the indexes. We have that available on the class. There we go. And we also pull off the indices here. So we're going to be adding 6 vertices. So we can start with the indexes of these. Thing is, I'm not entirely, because we're going to be rendering every single vertex, we can actually get away with not having an index buffer, which we might want to do. Yeah, let's start by focusing on the vertex data. So for our vertex data here, we are going to be pushing new vertices. So what we want to do is we want to push back an object. Now for this, we need the x, y, and z coordinates first of all. And since this is a positive x face, and this is our local position, we want to center a chunk around 0, 0, 0. So that means that if we have sort of a normalized idea of what our x coordinate is, what we should be doing is we have our x coordinate. We want to add 1 to that so that we're on the positive side. And then from that, we're going to subtract half of the number of edges, but we want to do that floating point. So that's going to be 2.0. Then on the y coordinate, this one's going to vary a little bit depending on where we are. We're going to start with nothing added to it. So it's going to be plus 0. And then we have a z coordinate. This one's still going to start 0. Then we have our w coordinate, which is 1, floating point, of course. We're just slowly working our way through these coordinates. So then we have texture coordinates, s and t. We're going to start with 0, 0. And then we have a normal for this face. This is an x positive face. So normal x is going to be 1. Normal for the y, z, and w are 0. 0 for the normal because it's a direction. And then we pass in the material, and we're getting that in as a parameter. So that is the first vertex that we want to push back. Let's just check that that line at least compiles. Yeah, so I'm getting a lot here. So we cannot narrow from type block T to GLUint in an initializer list. And what I actually want to do here is I want to reduce the size of a block T to a 32-bit integer, rather than just narrowing it, because we're not using anything that big yet. So we have a function that doesn't match that, because the x negative face still has the indexes thing here. But apart from that, we should be fine. It looks like this works. So now we need to add the other 6 edges. So we're going to add the 2 neighboring edges of the first one here, or the 2 neighboring vertices of the first one, which is plus 1 on y and z. Then we need to correct texture coordinates by adding 1 to both of these. Then we're going to repeat those 2. And then we're going to add one more vertex here, where we add 1 on both y and z. And our texture coordinate is 1, 1. So that should do the vertex buffer data, which is great. Now I am pretty much deciding that I want to ignore indices completely. So we're not going to render with indexes, which means that instead of finding an index buffer and then drawing elements, we can do GL draw arrays instead. And I want to draw these as GL triangles. So this simply means that we're not going to do an indirection through an index buffer. We're just going to draw every single point we have. And we are going to do vertex buffer data.size indexes. We're going to start at 0. So that makes it a lot simpler. We don't have to worry about the index data, as we're anyways just generating vertex data, and we're going to be drawing every single one of them. So for the x negative face is very, very similar to the x positive. We just have a load of zeros to make this the negative side of the face. And our normal out here has a minus in front here because it's negative x. So far so good. Oh, we're missing the block T material here. That's why it's complaining. We're just going to quickly fix up the rest of these definitions. There we go. Nice and simple. that. Now, way up here, I'm still passing in the index buffer data. Let's get rid of that as well. Because what I'd like to do is just validate that this works. And a really simple way of doing that is that we're just going to remove rendering of the Y and Z faces so far, so that these do nothing. And then we are going to just start that up. So that was built. We're going to switch over here and reload. So we're seeing absolutely nothing at the moment, which I would call a bad sign. Switch over here. Generating index buffer and vertex buffer. Putting vertex buffer data into it. That size, which seems about right. Index buffer is empty, but we're not using it, so it doesn't really matter. We bind it. We bind the various attributes here. That's good. What else? Oh, we're only doing this if the index buffer data size is greater than 0, which it never will. Let's look at the vertex buffer data size instead. Because we're not using the index buffer at the moment. So one more time. Still nothing. So we are gonna just do quick prints here. So what I want to see is I want to see a vertex count, which is the vertex buffer data size. And I want to see let's just do that on one line, dirt and line. And I want to move that out here, so even if the vertex buffer size is less or 0, we still get it output. And then I want to print any GL arrow we have. So GL get error. Let's take a look. So we've linked. Let's reload. So we're getting some vertex counts, and we're getting a 0 GL error, which means stuff should be happening. Thing is, it's not, which is slightly annoying. Just quickly switch back. So we're definitely doing something. Question is what? Okay, so 1, 2, 3, 4 elements here. And then the normal. Let's just check that this agrees with what we do up here. So we're doing this, and we have our ST parts here, normal or texture coordinates, and then we put up the normals, which is nice and simple. We set that to 0, and then we have our material at the end. So it seems reasonable. What I might want to do is I just want to print out what the material is. Material. I'm gonna look at just the first element of this. Well, actually, we're only going to do that if we actually have data. Otherwise, we're indexing it illegally. We're going to look at the material. I want to print that out and see what that is set to. Because if that's set very wrong, then weird shit might be happening. So we recompile that, switch over, refresh, and this thing's hung a little bit. So whenever we're printing the material, it's 1 or 2, which is reasonable enough. We'll switch back here. It's not really the issue because the material should be set correctly. Pull in the material, we hand it over here, and we use that to look up our texture. And for textures, we have 0, 1, and 2 set. So as long as we're doing 1 or 2, we're fine. So that should be no problem. So what else could be going wrong? So this is unsigned. We add 1 to it, floating point, so that should get converted to floating points. Then we subtract edges divided by 2 floating points. Looks fine to me. I'm gonna try and print out some more of this stuff. We're just gonna say stuff because this is gonna be a quick little session. So I want to see X, Y, and Z of the first one that we're printing out here. This. Link it. Get it all ready. There we go. We've built target long shot. Switch over. We run this. That looks fine. -8.5 is what I'd kind of expect for most of them. So not there. We're gonna try and add the rest of the faces, or at least we're gonna add the Y positive faces, because those are the upwards facing ones. We usually get to see those. So for Y positive, what we're gonna do is we're gonna take the Y offsets and move them to the X's. Y should be +1 because we're positive. Here, Z will vary. Texture coordinates are fine. Normals. We're Y positive, so we want the X to be 0. And then we want the Y to be 1 here. So it looks like that. And compile that. Fail to extra closing brace here. For some reason, I've managed to screw that up a little bit, so that looks a lot better. Let's try again. Let's reload here. Browser's a little bit pressured to do this, apparently. It's a little bit hard once we get into the bigger amounts. So nothing seems really off, but I'm kind of also worried that it feels very, very slow, which is usually also a bad sign. So we're generating our vertex buffer. Oh, I'm transferring buffer data to the very, very, very wrong buffer there. Let's try that again. Okay, so yeah, you missed that. Wrong thing. GL bind buffer here, or buffer data, was putting into the element array buffer and not the array buffer. We want it in the array buffer. So we're trying that. Let's reload. Well, nothing, but we're at least getting our skybox now, which I guess is an improvement. Still becoming slow as hell. That might, however, just be because we're logging a lot of data right now. because I'm logging this stuff on every iteration. I'm gonna stop doing that. So stopped logging a hell of a lot of data here at the bottom. Yeah, this is the number of triangles that I need, or number of vertices I need to render triangles for. That seems about right. Yeah, recompiled that already. Gonna go refresh over here. Yeah, that seems a lot more responsive now that I'm not logging a lot. But still something's off because we're not really rendering anything. So we have a lot of vertex buffer data, which seems to be correct. So we generate our buffers. Just check these two, add them back in. So for every chunk, we get that. We look at it and look at the other side. And then we add faces if necessary. With all that done, we bind our vertex buffer and then we transfer data using the size of the values of type unsigned int may not fit into the receiver type GL size iPointer. So we're taking our vertex buffer size, number of elements, times the size of every element. Then we take the data and say that's static draw data. Then we transfer index buffer. And local vertex data is this thing because I've removed the other one. That shouldn't be a problem. Try adding that debugging information in, see what happens. So reload. Yeah, we're generating lots of vertices and empty index buffers, just as expected. So that's good. We're using draw arrays. Let's just take a look at the documentation again. Who knows? Might be something there. So I want to see GL, no, not GL, draw arrays. There we go. Drawing, draw arrays. Mode, first, count. Okay, so we're starting. So mode, first, count. This is why you should never guess stuff. Mode is correct. This is the first vertex we're drawing, and then we're drawing 0 of them. So what we want to do is we want to start at 0. So the first vertex one we draw 0, and then we want to draw this many of them. Let's try that instead. So we're linking. Let's just get the browser ready. Everything's linked. I'm going to refresh. And we're actually seeing stuff. We're missing half the faces, but that's just because we're missing half the faces. We're just missing the implementation of that. Should be no problem. Let's get those remaining faces done. So Y face negative here. So negative Y face is 0 on the Y. And then we're going for -1 on the normal. Then we have the Z, we're going to move the Z offsets from Z to Y, because that's the one with zeros. And then this is Z positive, so we want to add 1 to Z. And then we need to correct the normals out here. So this should be 0. I'm just going to get rid of all the negatives first. 0. And then the offset on Y, it's 1. And then we have Z negative here. That is 0 on the offset on the Z out here. There we go. And minus 1 on the normal. We recompile that, we switch over, refresh. So now we're actually rendering both sides, and most of this is grass, which is wonderful. That is kind of what I would expect at the moment.